In all of the piecewise functions we've looked at so far, the endpoints of each of the segments have matched up with one another exactly, which makes the graphs continuous. There are no breaks. Now, when this is the case, we can choose to include these boundary values, these values of x where you switch from one part of the function to the other, to be in either of the two parts of the function that come together at that point. We don't want any overlaps, however. So in the case of this last function we were looking at, we initially included the x equals 0 point in the parabola part of the function, which is why we had 0 is less than or equal to x is less than 3 as the domain for this middle piece of the function. We could, however, instead include 0 in this first linear part, the negative 1/2 x minus 4 part of the function. If we decided to do that, we'd have to switch up our inequalities over here. So instead of having 0 is less than or equal to x right here, we would have 0 is less than x, and we would switch the equal to part to be over here. So the domain for this first line now is negative 5 is less than or equal to x is less than or equal to 0. We could do the same thing with x equals 3. Right now we can see it's contained in the f of x equals x minus 4 portion, this line right here. We could instead include it in the parabola if we just made x is less than or equal to 3 instead of x is less than 3, and if we just switched this to a less than sign. Sometimes, however, piecewise functions aren't continuous. They often have breaks in them. But sometimes piecewise functions aren't continuous. They often have breaks in them, as we can see in the two functions I've drawn here. Now, if we want to show that a certain point is not defined on a function, or in other words, if we want to exclude its x-coordinate from the domain, we just draw a little open circle at that point, like I've done in several places here. Now, for each of these two piecewise functions here, I'd like you to decide which of these endpoints should stay open and which ones should be filled in, based, of course, on how I've defined the domains for either of the functions. If you think an endpoint should be filled in, just click the circle that's at that endpoint. And if you want it to stay open, then just leave it open. Don't mark it. To double check your work, you can make sure that there's no x value on either of these graphs that belongs to two different parts of the functions.